At the dawn of time, man has had but one question. Would you rather have unlimited bacon but no games? Or games, unlimited games but no games? People have argued, debated, quarrelled over this question for centuries, and yet still people do not know what the correct answer is. But I am here today to prove mathematically which of these two you should pick every time, which one will get you the most gain, the most benefit if you were to pick this answer in this question. So we're going to start out by defining these two conditions in terms of logic. We're going to have logical statements that define what these two are. So the first one, would you rather have unlimited bacon but no games? We're going to define bacon in terms of B, and this is implying, so whenever B is true, that we have unlimited bacon, we will have no games. And we're going to define games as a capital G, and this little right angle means not. So having bacon tells us that we have no games. Our second statement is saying that having games implies that we have unlimited games but no games. So G is going to imply that we have games and we have no games. So now that we've defined these two conditions of the question, let's work them through, do some truth and false analysis, and see what condition would lead us to have the most gain, the most benefit. So starting with this first one, bacon implying no games, we can write this imply symbol in a more simple way, a way that makes it easier for us to understand, because implies it's quite an odd thing. You can have the right condition but not always the left condition. The left condition just tells us that when it's true, the right one will be true. So instead we can write this as having no bacon or we have no games, because if the left side and we do have bacon, then we know that we won't have games. But this is telling us that when we don't have bacon, we could have games, or when we don't have games, we could have bacon. An easy way to understand this and break it down is by using a truth table. So this is going to tell us when one thing is true and another thing is false, or true and true, false and false, what this result will look like and lead to, whether it's true or whether it's false. So we'll have a bacon category, a games category, and a bacon implying not games. Now, bacon can take on two states. It can take on true, or it can take on false. You can have unlimited bacon, or you can have no bacon. So we'll write it as such. Similarly, games can take on two states. You can have unlimited games, or you can have no games. So we'll write it in this format, showing the different combinations of true and false games and bacon. Brilliant. Now, let's analyse what happens in terms of this truth table when we have bacon and then therefore we don't have games. So this statement tells us that when we have bacon, we have no games. This first condition is telling us that when we have bacon, we also have games, because it's true and true. Therefore, this first statement is actually false, because having bacon is telling us that we have no games. However, this row is telling us that when we do have it, we also have games. That's false, according to our statement. Now, looking at the second one, we have bacon and we don't have games. This holds for the condition where bacon implies no games, because having it is implying that we don't. Now, it gets a bit weird when you don't have bacon, or the unlimited bacon is false. Looking at this first one, this second equation, this is logically equivalent to this first one. So we just need to look for when we don't have bacon or when we don't have games. So looking in this row, one of these two has to be false. No bacon is false, therefore this statement is true, or this condition is true. Similarly with this bottom one, it's also true, because we have no bacon, or we have no games, or we have both. That's what the OR logic statement means. So this is telling us all the conditions of what we can and can't have, basically. And to sum it up, it is impossible for us to have both bacon and games, because when we have both, it doesn't work for the option. It's not an option for you to have both when you answer this in the question. However, you can have bacon, or you can have games, or you can have neither, because that's what these truths are telling us. So I think we've analysed this first statement quite well. I think it's best now to look at the second one, which is where games is implying to us that we have games and we have no games. Once again, let's write this implies in a simpler format to help us understand this. So we can either have not this first side, or we can have this second side. Which can be written like this. And through the rule of distributivity, we are allowed to take this term and OR it with both of these terms on the inside. So it will look something like this. We'll have not G, or we'll have G, and we'll have not G, or not G. Both of these can be simplified, and I'll show you how that's done. So with this first one, this is basically defining a constantly true statement. And this is because, like we said before, games can take on one of two different conditions. You can have games, or you can not have games. This OR is telling us that at least one of these is fulfilled, which has to be true, because games can only be in two states. So this first part of the logical statement is true. Right, and this second one is saying that we have no games and we have no games. Well, condensing that down, that's just the same as saying that we have no games. So overall, this logical statement has become, it's true and we have no games. The only way that I can sort of come up with what this means is that it's true, the original statement, you know? You will have no games, and the original statement will be true, that you have games, unlimited games, but no games, which we already know. So therefore, the second statement must be the obvious choice, because we're getting unlimited games. That's what the truth means. We already know that we're getting no games, but we're getting unlimited games as what the truth says. I mean, there's no other way to answer this question. I mean, I've been analysing it for years now. I mean, I'm going mental over this. You have to pick the games. Why would you pick the bacon? The bacon doesn't make any sense. It doesn't make any sense.